In this video, I would like you to look at the product rule. Suppose we have two functions, u and v, which are both functions of x. And let's have another function, y, which is product of these two. We would like to find out what is dy by dx is going to be. So to find any derivative, we need to find first the small change of y when x changes a little bit, right? So if we have a small change of x, that will cause small change in u and v. So we'll have delta u and delta v, and these two small changes will cause small changes in y. So our y plus delta y can be found as following the same rule as u plus delta u times v plus delta v. We need to find first the small change in y. So therefore, let's subtract our y, which is uv, from y plus delta y. So y plus delta y minus y is going to be delta y. And we'll subtract uv from this bracket, but first let's open it. So u times v is uv, u times delta v is u delta v, plus v delta u plus delta u delta v, and finally let's subtract uv. uv minus delta uv gone, and so we'll have now delta y, but we need to find what is the rate of change in y when x changes. So we need to create delta y by delta x, and we'll divide every term of the sum by delta x, and we'll write u delta v by delta x plus v delta u by delta x plus delta u delta v by delta x. When our delta x tends to 0, our delta u and delta v also will tend to 0. But also, delta u by delta x will tend to the normal derivative du by dx, because that's what the definition of derivative is, right? And so delta v by delta x will be dv by dx. So now, when delta x tends to 0, we're getting delta y by delta x is going to be dy by dx. This delta v by delta x tends to dv by dx. So we have u dv by dx plus v times du by dx. When dx tends to 0, we have derivative, right? We have du by dx. So we have here v times du by dx plus dv by dx will tend to the derivative, but du will tend to 0. And when we have to multiply anything by a number which tends to 0, which is so small that it is almost 0, so we're getting 0 for the entire term. So we have 0 and we're not going to write it. So now what we've got is the rule how to differentiate a function which is product of other two functions. So for example, so we have dy by dx equals u times dv by dx plus v du by dx. This rule is called the product rule. Alright, so let's see how we can apply this formula to some questions. So for example, we need to differentiate the following functions with respect to x. One is y equals x times x plus 3 to the power 4. That is A. And another one is y equals 2x plus 1 to the power of 3 times x minus 1 to the power of 4. You can try on your own, applying the formula that we just derived, or you can watch with me if you want to. So let's start from the first one. This function is in the form y equals uv, where u is x and v is x plus 3 to the power of 4. Okay? Using the product rule, we have dy by dx is, so we have u times dv by dx plus v du by dx. To apply this formula, first let's prepare all the pieces of the puzzle. So we have u, we have v, we need to prepare dv by dx and du by dx. So let's prepare them here. So where our u is. So if u is x, then du by dx is 1, isn't it? And if v is x plus 3 to the power of 4, then dv by dx is going to be 4x to the plus 3 to the power of 3. So we have, now let's substitute all the pieces into the formula. U is x times dv by dx is 4x plus 3 to the power of 3 plus v is x plus 3 to the power of 4 times du by dx, which is 1. So now finally we need just tidy up a little bit. If you notice that there is a common factor, it has to be taken out of brackets. If there are any multiplications to be done, then do them. So look, in these two terms, I noticed that there is a common factor x plus 3 to the power of 3 here, and I have x plus 3 to the power of 4 here. So I will take the smallest power out of brackets. There is nothing else that I can take out, so I have only x plus 3 to the power of 3 out of brackets. Inside of brackets, then I will have from the first term, if I divide the first term by x plus 3 to the power of 3, I will get 4x plus x plus 3 to the power of 3 taken out of brackets gives me x plus 3 times 1, which is just x plus 3. So finally, let's tidy up the second bracket. 4x plus x, 5x, isn't it? 5x plus 3 plus 3. So times x plus 3 to the power of 3. Okay, here is our solution. And let's try now the second question. This question is in the form y equals uv, okay, where our u is 2x plus 1 to the power of 3, and our v is x minus 1 to the power of 4. Let's find all our du by dx's and dv by dx. Okay, so du by dx, applying the chain rule, we have 2x plus 1 to the power of 2, and then we need to multiply by the derivative of the internal function, which is 2. So 2 times 3 is 6, 2x plus 1 to the power of 2. And now dv by dx, it is 4x minus 1 to the power of 3, and the derivative of the internal function is just 1, so we're not writing it. So now finally let's apply the rule and the product rule, and let's find dy by dx. I'm not going to write the rule again, but I would strongly recommend you to do this over and over again in your examination. U is 2x plus 1 to the power of 3 times dv by dx times 4x minus 1 to the power of 3 plus, as you can see, I don't have the formula just straight in front of me. It is just a little bit aside here, and it's already a little bit hard, so it's very, very useful if you keep the formula just in front of you to avoid any mistakes, plus v, which is x minus 1 to the power 4, times du by dx, which is 6, times 2x plus 1 to the power of 2. And now we need to tidy up. Let's look for any common factors from the numbers 4 and 6. The only common factor they might have is just 2. Let's look at x minus 1. We have x minus 1 to the power of 3 in the first term and x minus 1 to the power of 4 here. If we'll take x minus 1 to the power of 4 outside of brackets, we'll get negative power inside of brackets, which is not nice, right? So we are going therefore to take the smallest power outside of brackets. So we'll take x minus 1 to the power of 3. And also let's look at the term 2x plus 1. We have 2x plus 1 to the power of 3 in the first term, and we have 2x plus 1 to the power of 2 in the second term. If we'll take outside of brackets the bigger power, we'll end up of having negative power inside of brackets from the second term. We don't want that to happen, so we are taking the smaller power outside of brackets, which is 2x plus 1 to the power of 2. Now let's see what we are getting inside brackets. We took 2 from 4, so 4 divided by 2 is 2. 2 is left inside of brackets. X minus 1 to the power of 3 gone outside of bracket. So now we have 2x plus 1 to the power of 3. We took power of 2, so we're left only with 2x plus 1. Alright, now we took 2 from 6, so 6 divided by 2 is 3, so we are left with 3 here. 2x plus 1 to the power of 2 completely gone, and now x minus 1 to the power of 3 gone, and we're left only with x minus 1 to the power of 1. Obviously now we need to tidy up this big bracket. Okay, 2 to the power of x minus 1 to the power of 3 times 2x plus 1 to the power of 2. Please notice it's already not really nice to have a smaller power after the bigger power, so we are going to rewrite this so all smaller powers would be at the front. Okay, but first let's tidy up the second bracket, and then we'll tidy up finally a final answer. So 2 times 2x is 4x, plus 3x gives us 7x. 2 times 1 is 2, plus 3 minus 1 is minus 1. So finally our answer is going to be 2 times 7x minus 1 times 2x plus 1 to the power of 2, and times x minus 1 to the power of 3. That's the end of the video. Thank you for watching.